In this problem, we have water going off Niagara Falls. We're told it goes off the falls horizontally with a distance, a velocity of v naught, and then at some point down, some distance down y, we want to figure out its pointing vector theta. We want to know its angle below the horizontal. It asks, what is the pointing direction below the horizontal? So that's theta here. So a certain distance down, this is the pointing vector of the velocity. So some distance down, the velocity at this point of this little water particle is going that way. So we have Vy, Vx that we're going to use to determine this. Now, initially, this velocity is going straight over, so our initial velocity is our x velocity. Our initial y velocity is going to be 0. So why don't we write this down? We'll put in our axes, x and y, and we'll say our Vx final equals Vx initial, which is equal to v naught. Now our Vy initial is just equal to 0. Now our Vy final we can use by the formula v1 squared equals v0 squared plus 2ay, which is dependent just upon the acceleration due to gravity and y. So that's what we can use to find Vy. Now, the whole point of this is to find our theta in terms of Vy and Vx, but we want it basically in terms of the initial velocity v naught. So we could just write tan theta equals Vy over Vx. But we want it to be just in terms of basically y and v naught, what we're given in the problem. If we're actually given these numbers, could we solve this? We don't know Vy and Vx right off the start, so we want to figure out a formula with just y and v naught and any constants like g. So Vy we don't know, Vx we already do know is v naught. So why don't we determine Vy from this formula? This is our final Vy. So we'll say Vy final squared equals our v initial squared is just 0 plus 2. The acceleration is the acceleration due to gravity, which is minus g. The distance y is actually downward, so that's negative y. So we have basically Vy final squared equals 2gy. So we take the square root of this, we get Vy final equals root 2gy. So we can use that as this y here. So we have tan theta equals our final v, which is root 2gy, root 2gy divided by our velocity in the x direction, which is v naught. And so we solve for theta, because that's what we're looking for. So we just got to take the inverse tangent of both sides to give us theta equals tan inverse root 2gy over v naught. That is our final answer.